Okay, yeah. So again, polymorphism, so I'll just repeat this bit. Polymorphism generally means the same name, different behavior. So again, here all these functions will have the same name draw, but according to the object, it will have different behavior. It will draw either a circle, rectangle, square, triangle, whatever, depending on the object. So now again, like almost everything we've learned so far, polymorphism has two types, and that's static and dynamic. So again, static as usual means compile time, dynamic means runtime. Now, what is the difference in polymorphism here, right? So in static, it means the as usual, it's decided during compile time, and dynamic is runtime. But what it exactly means is the compiler. So it sees a function, right? It'll decide to call that function before the program is even run. It's like it has it like registered, okay. As soon as the program runs, I will run this function. Versus dynamic just means that it is decided when the program is running. So the program will be running and then it'll analyze its situation. Once you call it, it'll be like, oh, okay, so this is the scenario I am in. So I will need to call this is this function respectively. So quite similar to static and dynamic memory. But again, dynamic polymorphism here, it analyzes the situation it's in. It'll analyze, okay, this is the object I have, this is what the object looks like, this is blah, blah, blah. And I will call this as this function respectively. I have better example for it. So let's assume that I have an elevator, right? Let's assume I have a normal elevator. I press 5, it will go to the fifth floor. So that is essentially static polymorphism. It just does what you need it to do. It already knows. It already has a function. Okay. The person will enter a floor number. I will go to that floor number. That is static polymorphism. Now, for dynamic, let's say I have a really smart lift. Let's even take the lifts in our college, right? So if you press 2 and if one is at 3, one is at 2, sorry, one is at 3, one is at 1, it prioritizes the lift going down, right? So it'll like the lift in the third floor will come down. Or if multiple people have pressed the lift, it'll go all the way up and then pick everyone. So let's say I'm in a smart elevator, right? And so before making a decision of which floor to get off of, it'll analyze how many people there are. Then if it's full, it won't even open the door. Or if it'll analyze how many people want to get down on which floor. And according to that, it'll make a decision on which floor to get down. So that decision at that time, by analyzing its current scenario, is essentially what dynamic polymorphism is. Okay. So static again. It's essentially saying I have all the information I need. I will decide and run it immediately. It says, okay, it just takes an input, runs an output. It'll take my input, drop me at the fifth floor, and it'll drop me at the fifth floor. That's it. There is no decision, like major decision making at that time. But then dynamic essentially says, I don't have enough information right now. Let the program run. And once I get in that space, once I get into that scenario, I will decide what my course of action will be. That is essentially what dynamic is. And yeah, this is the lift. Is it? So I press the first floor, fifth floor, I go to the first floor, fifth floor. So that's static. And dynamic is press the fifth floor. It'll assess like the priority passenger, if there's like any emergency non-stop, if there's like so many people want to go here, here, here. It'll assess all that and then make a decision. So that is essentially what dynamic is. Also, it's important to note that dynamic doesn't essentially mean automated. It's not like AI or anything. It just, and it doesn't like randomly change your mind. You have hard coded all this with stuff like overrides and dynamic polymorphism, which we will get into. So you give it all the functions and you give it all the necessary conditions and it just selects it. So it's not like smart in a way, but that's just like an important distinction to make. But yeah, I think, yeah. So now when we look at polymorphism, we mainly have two partic we have two part oh wait shit, sorry. Does anyone have any doubts so far? A very base introduction. If you do have doubts, don't worry. Once we like go into it, it will be better. Any doubts? Any? Ashada Niramshi. Any doubts?
No.
Okay,
Mm,
well, so so polymorphism. When you look at polymorphism, the main two sections we will be looking at is overloading and overriding. So essentially, when you're looking at static polymorphism, you have overloading. Dynamic, you have overriding. So overloading, as I said before, it's essentially the same function, different meaning. Now, how this differs is the same function, different inputs. So depending on the input you give, it will call a different function. Now, how can you differentiate between the inputs, right? So input, as you know, is called argument. Um, that is also something we would have covered before that. And again, this is compiled in polymorphism. Oh, okay, I have not gone detail in this slide. Okay, so that is overloading. We'll look into that in detail in the next slide. And then overriding is the same function but different inputs, different objects. So here, different inputs, like different parameters in your function. So this is my function. I will change my parameters here. This is what leads to overloading. But here it is different objects. So if I put like a dot one object and some function, I change this, and according to this, this behavior would change. So that is overriding. So you can only know your object after you run the program and after the user interacts with it, right? So it can only happen during the runtime. So that is essentially dynamic polymorphism. So that's why we say that overriding is dynamic. So the object changes the function call. So it is done when the child or derived class has a function with the same name and parameters and return type, and the function overrides it. So again, here we change the parameters. Yes. Now for overriding, you cannot change your parameters. So let's say the base class has a function show. The derived class should also have an identical function show. It cannot change in parameter because if you change it becomes overloading, obviously. So it'll have the same name, parameters, and return type as the parent or superclass or base class, whatever you guys want to call it. And that function overrides that of the base class. Okay. Uh, this is derived. No, the function that then that function derived overrides that of the base class. So then that function, I am so sorry, is overridden by that of the child class. You guys saw nothing, okay? That did not happen. So, other words for this, and you really do not need to know this, but Subin sir had it in his PPT. So, dynamic polymorphism is also called dynamic memory dispatch or runtime polymorphism. I think I mentioned polymorphism runtime before, but this is new. Any doubts so far? Again, once we look at examples, it will be much clearer. I've gone into it in much more detail, but any doubts, like any basic one? I'm assuming there are none. So let's just again, this will become much clearer. So overloading. We'll first look at overloading and then overriding. Again, a reminder that overloading is static polymorphism. It happens during the compile time. So overloading will mainly be looking at three different types: function overloading, operator overloading, and constructor overloading. And under operator overloading, we have arithmetic operators and input output operators, right? We look at each of it, what each of them mean, what each of them looks like in code, and some common like errors you should avoid while coding this. So first of all, function overloading. So the compiler decides the function to call. So it's exactly what we've been talking about so far. So depending on the parameters, essentially the function decides which function to call. So it'll have multiple functions with the same name, but different parameters, right? And it'll decide what to call. Now, how do I differentiate between the parameters? Like what defines? Okay, this is a different parameter. So first would be the number of parameters. Let's say something like this, a function, void show with one parameter, two parameter. So if I have an object A and I call show and I give it one input, then it will call my first function. Let's say I have two inputs, right? Let's say I have one comma two. Then it will call my second function. It's as simple as that. It just depends on the number of parameters. Next, the type of parameters. Let's say I have again my object A, show. If I insert an integer, it will go here. If I insert, let's say, here I given double, so it's a decimal, so 0.5, it'll call this function. Again, if I have, I know what are the other types. If I input a string, it'll go to that. Or if I have like no input at all, then it will go to that particular function. So it differs based on the type. And then finally we have order, which is a combination of this, let's say. So first integer, double, double integer. So if I have show 1 comma 0.5 and show 0.5 comma 1, according to polymorphism, it will go to their respective functions. So essentially the compiler, it will look at what we've given and it'll just look at this function definition. Once it matches a particular criterion, so you see how this matches this criterion, it'll go into that and run its function. So why is that important to understand? We will look at. So when we're looking at errors, stuff you should not do. If you just change the return type, this will not lead to polymorphism. Because as I said, the compiler looks at this. It will look at, okay, let's say I have this. It'll look at this. It'll look that its criterion is that the function should have one integer input alone. And if you look at these two, they both have one integer input. It will not look at this like at all. Because to it, this is the return type, right? So no matter what happens in the function, the function will define what the return type looks like. So it will just look at this. So according to the compiler, both of these criterion match this one. So it won't know which one to call. So no polymorphism here. So this will just result in an error. So another thing you need to be careful about is when you use default parameters. So just to recap, let's say void or something. Default parameter essentially saying a is equal to 0 in. So again, you guys should know this. I'm just giving a small reminder. So let's say I do not input anything when I call this function. It'll take a default value of a is equal to 0. If I do input, let's say 1, then it will just replace the 0 with a equal to 1. So that's kind of how default parameters work. So yeah, so caution is working with default parameters. Why do I mention that? So let's say I do not have space here. Oh, I can do this. Haha. Okay. So let's say I have an object A. And wait, let me first define my function. Let's say show void or something. And I have int A, input int A. And then I'm having a default parameter int B is equal to 0. Now I give my object A dot show int A. Let us say 1. You know what? Let's remove this for now. That'll be easier to understand. I don't know how it does. Okay. Let's say I do this. Mm, okay, previous one was correct. Okay, let's say I give an input of one. Yes, and let's say I have another polymorphized function with just in p. So now this object, which one would it choose? So if you do it separately, both this can run because it just defaults the value of int p, or this can run because there's one input. So when the compiler looks at it, to it, both the criterion are already met. It needs one input, like it compulsory needs one input, and that is met by both. This can be randomized by the compiler based on the given information. So here, this will not result in polymorphism. So caution while working with default parameters, having the same parameter type for all parameters involved, and just adding the default parameter will result in polymorphism. So again, the same example. This would cause confusion because if I have a dot show 1, both of these criterion are technically satisfied because this is the default parameter. So whenever you're working with functions, it should not just differ by the default parameter. Just make sure you have that in mind. Or another thing you can do is you can change this to double or like a different type. So that will also fix this up because it obviously knows that this one isn't this or is not considered good coding practice. So definitely do not just defer it by your default parameter. Is this fine? Like this particular one is okay. Any doubts so far? Harish, you're unmuted, but I cannot hear you. So if you're saying something, I'm sorry. Any doubts? Niranjani, Hashira?
Hello.
கேக்குது.
Okay. No, could you just repeat the causes confusion part?
This one? Yeah, sure. So we
Even
all
the
know.
like parameterized one, copy default parameter.
Yeah, sure. So you guys know how default parameters work, right?
Mhm.
Should I explain that to that? No problem for me. I'm just asking.
Yeah, sure, sure.
Yeah.
Explain it.
mm,
Yeah, I should explain it. Yeah, you guys know.
Yeah, explain it, explain it. Explain. Just in case I
Okay,
might have missed
done.
anything.
Okay. So let's say I have sure. I'm just vetoing the void. I'm just ignoring the void for now. So default parameters basically how it works is it tells a function. Okay, so I can take this default value. So I don't need it, like I do not exactly need it from the user, but if the user gives it to me, I'm happy to use it. That's essentially what a default parameter tells the compiler and the user. So we have show, and so essentially each object has A and B, right? I'll just make this obj. Each object has a value of A and value of B. Now, tentatively, according to this function, or not object, just function in this function. So tentatively, I will save my value of b as 0. So if the user, for whatever reason, they just give me my first value, then my compiler will take this as it is. It will take my value of b as 0. It will be happy. It doesn't show any errors. So essentially it tells, okay, so the user didn't give me this. Okay, I'll use my default value. That is a default parameter. But if the user gives me for A1 show, and if they give me 1 comma 2, so the compiler looks at this and says, okay, so the user has been kind enough to give me the second value as well. So then it will take A as 1 and B as 2. It will forgo its default value. It will be like, okay, so it's given to me, I don't need to use my default value. It essentially works like that. So let's say, like in when you're filling your personal details and it asks for a secondary phone number or something like that. So primary phone number and secondary phone number. So maybe in the function, this would be a compulsory parameter, like this won't have default value, and this default can be equal to 000 or XXX, whatever. So essentially, when you're inputting it, you're telling the compiler, okay, I definitely need a primary phone number, but it's okay if they don't enter a secondary phone number. I can take a default value of basically null. Is that fine? Like, is that concept in itself okay?
Yeah, that makes sense.
Yeah.
Ah,
Mm.
so now how does this affect polymorphism, right? So let's say I have back to my show function. Let's say I have int, just your regular function, right? And then I have void. Oh, the meeting's ending in 10 minutes, guys. Just a heads up. And show int a, and I'm having a default parameter int b equal to 0. So now let's say my user for object A in the function show, they've only given me one. Okay. So when you look at this function alone, and in this function's perspective alone, it will say, okay, I have my one integer input. I am happy. I'm okay with that. And it will run. And when you look at this function's perspective, it will say, okay, I have one integer. I haven't gotten my second integer, but I'm okay with that because I have a default value of b. So I will still continue to run. So according to this definition will run this and this. It is okay with that. So the compiler really can't differentiate between these two because, as I said, the compiler will go to each function, it'll check, okay, is my criterion satisfied, and then go for it. Go for it. So right now, both of its criterion is satisfied, right? So this results in a bit of a confusion, and hence polymorphism won't work here. Is that fine? Is that clear up, Nancy?
Does this throw
That's
an
pretty
error or
clear.
like do both run?
Yeah, it'll throw an error
Ah, okay.
because again,
Yeah,
it
that
doesn't
makes
know which
sense.
one to run. Yeah.
Mm-mm.
Eventually, you were saying?
No, I'm saying it's pretty clear.
Okay. Everyone else, is that fine? Yeah, I'm assuming it's okay. And just tell me to go back to it anytime. That's fine. So yeah. Finally, changing the parameter's name will not result in polymorphism. This is pretty understandable. So if I just change A and B, that definitely will not result in polymorphism because these names are just how you reference the value inside the function. It doesn't have anything to do with the input type. So these are some main stuff you should look out for. Now, just a small example to understand polymorphism, like at least how it will look like in code. I didn't like pick up too many because all of us have already worked with them. So you have int A, int B, and then three inputs. So this particular call for will call this, and this would call this according to the number of parameters. Similarly, all the above you implemented, you will get your function. It's pretty simple. Now let's go to the second type of overloading, and this is operator overloading. So this is very similar to method overloading. In fact, most of the errors are the same. How does this differ? Operators, as we know, it's like stuff like plus, minus, divided by, modulus, whatever. So why do we need to define operators? Let's say I am making a particular data type. Let's say I'm making a special type of number called number, or like so we already have a default int float. What Yeah, we have int float and then string, and we have all our default data types. Let's say I'm making a new one, a new arithmetic data type, let's say. For example, complex numbers. Complex numbers are not defined within C++ or CPP anywhere. So I'm defining a number, I'm defining the class of complex numbers. So for this complex number, let's say I want to make an addition between two complex numbers. When I give a simple plus, the compiler will be confused. It'll think, oh shit, wait, how do I add these two numbers? How do I I've never seen this data type before. How would I add it? Or how would I subtract it? How would I divide it? So defining that is what we call operator overloading. So the same operator, you have the same plus minus divided by etc. But you have different behavior according to the numerical type. Sorry. So that this numerical in particular is what we call arithmetic operator. Input-output operator exclusively deals with your Cin and Cout. So how you take an input, how you take an output. So if I simply just give, let's say I have ABC number type. I give input ABC from the user. The compiler will think, how do I input this value? Like it's so complex. How do I input it? I don't know how to input it. Similarly, I don't know how to present it to the user. How do I output it? So defining that according to the object is what we call input-output operators. So both arithmetic and input-output operators together is what we call operator overloading. So again, this will be much more simpler when we break this down. So first we will look at arithmetic. So let's say I have a plus b, and the compiler will see this plus, and it will think for my part. Let's say my a and b, as I said before, is the ABC number type. Okay, so it doesn't know what this is. Essentially, we have defined something called ABC, but all the functions related to it you have to define. So it'll think ABC plus ABC. So the compiler will look at this plus and look at ABC and look like, okay, do I have any function defined which tells me how I should behave for this? So it checks if there is any definition for this plus operator in ABC in particular, and it converts it to a form like this. Essentially, ABC is my object one. Let's say ABC 1 and 2. ABC 1 dot operator. And operator here is plus. So dot plus. It's like a function call, by the way. So normal function call will look something like this, right? And one. This is what a normal function call will look like. It will convert this into something like this. Operator plus, because right now we're looking at plus. So this, and then A, B, C, 2. So this will be my base object, my function, and my input. Base object, function, input. So it will look at this and convert it into a function called sorted. Okay. And then it runs. So since it converts it to a function, we can say that it follows the same um, error scheme as function overloading. But before we look at that, is this topic in itself okay? Like, is this understandable so far? One more person, if you guys can confirm. Continue. Yeah, I know 2 minutes left. I'll look inside. So again, it works just like method overloading or function overloading. Here, these are our functions, plus, minus, multiplication, division, all that. And the operand in particular, so A plus B, this is the operator, this is the operand. So our operand is our object. And depending on the type of operand, our operator will behave differently. That's all there is, right? And one important thing to note is it only works for user-defined operand type. So it only works for user-defined objects. So I can't define int for int, plus, minus, multiplication, division. All that is already defined by the compiler. I cannot go and say, okay, all this will behave differently for int. I can't say that. I can only make a separate data type like complex or number or ABC, as I suggested before, and I can only define all of this for stuff like this. I can't define it for inbuilt data types. Uh, okay. So, okay, there's only 1 minute left in the meet. I will make another link and we can join them. Is that fine? Wait, sorry. Uh, yeah, I'll make another link.